Good morning. We are going to look at finding a determinant this morning. And finding a determinant is going to be useful for you to find an inverse. An inverse is going to be useful for you to uncode a message later this week. But today's lesson is just find a determinant, find an inverse. It's nice and straightforward, not terribly difficult, but you do have to remember what the steps are because we're not actually going to prove this. Okay, so for finding the determinant in a 2x2 matrix, and you should be happy I'm only going to keep you to a 2x2. I might show you how to do a 3x3, but anything past a 2x2, finding the determinant it gets complicated. So let's take a look at our matrix A. To find the determinant here, all we're going to do is multiply this diagonal and we're going to subtract this diagonal. Okay, and if you do arithmetic, plus 10 equals 6. Okay, this number is important and it's going to be really useful when you go find it. Go find our inverse. And we're going to use this matrix. So keep this in mind. I'm just going to go ahead and like that, and we'll come back to that in a second. If you want the generic formula for finding this determinant, you just go ahead and look as A. I'm going to give it some variables here. And the way you would write this is that the determinant of A is going to equal to A times D minus C times B. Okay, fairly straightforward. What we're going to do next is find an inverse. We're going to find the inverse the long, hard way. And then from there, it should be kind of slightly obvious how the determinant's involved and come up with a generic formula. Okay, so we're going to again just go ahead and just figure out the inverse of a square matrix. The nice thing about finding the inverse of a square matrix, if you take A times its inverse, you're going to end up with the identity matrix. Now, we talked about taking a zero matrix and adding it to a matrix, and you get the same matrix out. Well, this is the same thing, except for the fact that we're going to be multiplying. So in other words, if I took my matrix A and I multiplied it by our identity matrix right here, an identity matrix, regardless what size it is, will always have ones running down this diagonal. And zeros there, and you multiply them together, and I think you guys have done a problem like this. You end up with the same matrix out. Okay, this is useful when you're finding your inverse, because you know this matrix times its actual inverse has to equal that. So if we don't know what this matrix is, we can put some variables in and then maybe try and solve. And that's what we're going to do. So let's go ahead and take -4 times -2. 5 and 1, there's our matrix. Multiply it by some matrix we don't know, which is going to be our inverse. And we do know this all has to equal 1, 0, 0, 1. Okay, well, let's use matrix multiplication to go ahead and multiply. So we take -4 times -2 times WX, and we're going to end up with a really kind of ugly looking matrix here, but it's not that bad. So -4 times W and Y is -4W minus 2Y. Put those in parentheses here. Now we're going to take -4 and -2 and multiply by X and Z, and you end up with -4x minus 2z is our top row of our new matrix. Now we're going to do the same thing down here. We're going to take 5 times 1 times W and Y, and we get 5W plus Y. And then we end up with 5x plus z. Okay, all this, oops, there you go, is going to equal 1, 0, 0, 1. Well, now we know, okay, so we got a 2 by 2 equal to a 2 by 2. This element is going to equal this element. This element is going to equal this element. And we're going to end up with basically a system of equations. And don't freak out. And over here, we're going to have that's going to equal 0, that's going to equal 1. Okay, I'm looking at my notes here. All right, so we have these 4 equations. Let's go solve for W and Y. Now, from here on out, it's just meticulous algebra. We could say right here, with a dashed line, I'm going to have to switch pages, but I'm going to go ahead and move the page up. I'm running out of room. That Y equals minus 5W. Now, if I take my Y equals 5 minus W, and I substitute it back in here, I end up with minus 4W minus 5W times 2 equals 1. So I get minus 4W plus 10W equals 1. That's 6W equals 1. W equals 1/6. Okay, I take my W equals 1/6, and I'm just going to keep going back up here. Put it back into this equation. Now I get 5, 6 plus Y equals 0. Y is going to equal minus 5, 6. Okay, easy peasy. So now we got two. We got two variables we figured out. Y, W, and Y. All right, let's go back up here and solve for Z. Well, Z is going to equal 1 minus 5x. Substitute it back in. Minus 4x minus 2 times 1 minus 5x equals 0. So minus 4x minus 2 plus 10x equals 0. So we end up with 6x minus 2 equals 0. 6x equals 2. X equals 2, 6. I'm going to go ahead and leave it as 2, 6 and not simplify it, and you'll see in just a second. Okay, so we found our x. Let's put our x back in here. So we get 5 times 2, 6 plus z equals 1. I'm just going to go ahead and z equals minus 4, 6. Okay, so there you go. We now have all 4 pieces to make our inverse. We have x equals 2, 6, z equals minus 4, 6. So a to the minus 1, our inverse of matrix is going to look like, and I can get this out of the way. 1, 6, 2, 6, minus 5, 6, and minus 4, 6. Okay, that's our inverse, all right? That's kind of long and complicated. But let's go back and take a quick look at what A looked like and what our and we know the determinant of A is equal to 6. Okay, there are some patterns going on here, right? Just a really quick notice, everything here is divided by 6. Well, that's just 1 over your determinant. That's true. So you're going to multiply your matrix by 1 over your determinant, but something else also happened. Your 5 and your minus 2, make sure you get this right. I think I wrote this down wrong. Double check. 6 minus 4, 6. Did I write this down? Oh, sorry. Yes, your A and your D swapped. Okay, I was about ready to say it backwards. Okay, so you divide everything by 1/6, but your A and your D swapped, and you're also going to end up. These guys also become the opposite sign. Okay, so A and D swapped, and 5 and minus 2 are going to change signs. Otherwise, you're multiplying it straight across. So what you're going to do is to find A, to find your inverse, you're going to take 1 over the determinant of A, and you're going to multiply it by you're going to swap these guys. So 1 minus 4 gets swapped, and these guys become the opposite sign. Okay, where okay, in this case, A equals minus 4. So 1 and minus 4 swap, and then this becomes a minus 5 because of positive 2, and you multiply it by 1 over your determinant. And that's how you find an inverse. You're going to do a couple of these, and what I called it a quiz on your assignment, but it's not a quiz. It's just, it's basically your classwork. But the thing is if you get it wrong, you can go back and do it again, okay? And it should give you a little bit of feedback as you're working through it. So please go ahead and work those problems, and it will automatically submit it. You'll be able to submit it at the end, and you can resubmit it. So don't forget about it. It's just the only way I can do a form where you guys get feedback is to actually, use their quiz form, but it's not quote unquote a quiz. Okay, so with this in mind, the fact that we're not doing anything greater than a 2x2, go ahead and start working your problems. On the live session tomorrow and Wednesday, we'll go ahead and do another example. Good luck. Email me if you have any questions.